As we have seen in previous lessons, children in first grade are expected to work with 4 different classes of word problems, each of which have 3 subtypes, and some of the subtypes have variations. Some of these problems are known to be very challenging to first graders. Therefore, it's critical that we think intentionally about how we're going to support the learners when they struggle. What we aim to achieve is what I call positive or productive struggle. We want children to realize that it is a normal characteristic of learning to be in a situation where we aren't quite sure what to do or we're still actively trying to make sense. We want them to see that struggle can help them learn things more deeply. However, we're also going to encounter children who are frustrated and they've gone into a mental state where they're ready to give up. While they're in that state, there's very little learning going on. But when they calm down, we want them to see that there are tools that they can use to help them cope with the struggle. In this lesson, we explore effective and ineffective strategies for supporting first grade problem solvers as they engage with difficult problems. This slide is actually how we ended the previous lesson, and I just want to revisit the first bullet point. Children's difficulties with word problems are most often at the level of comprehension. If they can't comprehend the problem, they don't know what to do with the numbers. I mentioned earlier that children often avoid comprehension by asking other people to classify it as addition or subtraction, or alternatively, you see kids sometimes arbitrarily choosing an operation based on what has been most recently studied in the classroom. When children avoid developing comprehension strategies, they're not only damaging their capacity to be a good problem solver at the first grade level, but they're also building a very weak foundation for subsequent problem solving. Therefore, our approaches to helping and supporting first grade problem solvers must include specific techniques for fostering sense-making, and not just sense-making of the numbers, but also the capacity to make sense of and model the mathematical relationships that are embedded in the words. We're trying to move our first grade learners to more sophisticated levels of strategy, so it does also make sense to ask them about their decision-making skills for how they decided to work with numbers. For example, as students share a diversity of strategies for solving a word problem, we need to ask them 2 kinds of questions. How did your work here with the numbers match the words of the problem? How does it represent that situation embedded in the words? And then we also need to say, and how did your strategy make sense for these numbers and for what we know about how these numbers behave and are related to other nearby numbers? Problems often require prerequisite knowledge and skills, and so we can support our learners by making sure they've had the opportunity to develop those prerequisite skills before we thrust them into problem-solving situations requiring that knowledge. Our final proviso as we plan a learning trajectory for our students is that we must gradually build complexity and variety into the problem-solving experience. Our goal is not to get the children to the point where they can almost mindlessly do word problems. Our actual goal is to help them get to the point where they can do more complex word problems. So we want to continually build their expertise and keep them mindful. If they're finding these problems easy, let's up the ante in terms of giving them some more complexity, such as multi-step problems or harder problem types. So comprehending word problems or making sense of situations and mathematical relationships that are embedded in the words, this is critical to the development of good problem solvers. Let's take a look at some characteristics of children who are good at making sense of word problems. They can retell the problem in their own words. They can visualize the numeric relationships that are embedded in the words. They can use this awareness of how quantities are related to translate words into the language and symbols of math. For example, writing an equation that matches the situation exactly. Finally, they can make sense of a variety of approaches, considering how they're similar or different, and being able to identify ways in which some approaches are actually more advantageous than others. You will notice that most of these sense-making strategies require children to spend time thinking about a problem before they operate on any numbers. Research shows that good problem solvers study a problem before they begin trying to solve it, and that poor problem solvers tend to immediately try to pull out numbers and do something to them. Therefore, a good portion of your effort to increase sense-making is going to involve slowing them down to study the problem before they try to do anything with the numbers. The last bullet point is best addressed by having students solve problems in more than one way, or another alternative is to have them engage in a strategy share, a dialogue with their peers where they can see and try to make sense of how somebody else went about solving the problem. Children, like all humans really, often prefer to avoid the struggle of making sense, and I've previously mentioned some of the strategies they have for doing so, like getting a teacher or parent to identify what operation is required, or choosing an operation arbitrarily based on what they've been studying recently. Another technique that you often see children use is the keyword approach. In this approach, the student comes to recognize that certain keywords are often associated with certain operations. For example, they might associate the expression give away with subtraction. It is actually dangerous for children to arbitrarily choose an operation based on one or two words in a problem. Why do I say dangerous? Well, if children do not do the work of making sense of the problem itself, instead of just pulling out a couple of isolated words, they will surely struggle with word problems in the future, which are not likely to come with easy clue words. Keywords aren't always present in problems. They certainly won't be present in problems of the future. And if children don't learn the sense-making strategies of first grade problems, they won't have the foundation for making sense of more advanced problems that don't contain keywords and that contain multiple steps and multiple operations. Also, another important reason for talking about it as if it's dangerous is that keywords are not always reliable. There are completely valid uses of keywords that would result in the exact opposite operation that a child might expect. Carpenter, Hebert, and Moser showed that children rarely solved word problems correctly if the keywords appeared in the problems but were irrelevant to the solution. And last year, I've discovered that personally with some data that I collected in a research project. I was doing a comparative research project at the first grade level and working with a teacher who was using a conceptual representational approach that was more like the Common Core. Concepts first, then procedures. And when the concepts are being learned, lots of different visual representations for making sense. So children were really focused on trying to make sense of the situation and represent it before moving into the problem solving. So one of the interesting things that came up on the post-assessment that was given to all of the children at the first grade level was this problem. Jolie had some candy. She gave 4 pieces of candy to Lucy and 3 pieces of candy to James. How many pieces of candy did she give away? There was one class of students in the research group. Only 5% of those students incorrectly used subtraction here. There were 4 different first grade classes that had been using more of the traditional approach, and 34%, more than a third of the students in those classes incorrectly used subtraction, presumably by noticing that the problem involved giveaway. If they had modeled the actual problem, then it would have been clearer that it was actually not a subtraction problem. So as a teacher then, we know that we need to avoid the keyword approach, and we also need to give children actual problems where they're going to see the danger of that themselves because the clue word gives them the wrong operation, so that students can begin to see, oh, that might not be the best strategy for me. That might lead me into trouble sometimes. We also need techniques for slowing down the process of studying the word problem and making sense of the mathematical relationships. Now, you don't need to tell the students what type of problem you're giving, and you're actually discouraged from doing so. First grade problem solvers are at the beginning of their learning journey with word problems, and they really need to develop strategies for making sense of them for themselves without the teachers and parents doing all the hard work for them. So in other words, avoid situations where you tell students to add or subtract, join or separate. It is acceptable for you to have the students tell you what's going on in a problem, and you're also encouraged to foster their visualization skills. Prompt them to act out problems to support their sense-making when they have a problem that's really difficult. While not all students will model all problem types, acting out problems continues to be a powerful tool for sense-making, and it should be employed as needed. Another role you can play is to support their capacity to work with numbers flexibly, but that's a topic that we're going to be discussing next week. As we think about strategies for supporting learners in that first stage, slowing them down to make sense of the problem and study it, it's important to recognize that solving the word problem really involves 3 steps. First, we have to convert the words to an arithmetic problem, step 1. Step 2, we solve the arithmetic problem. And step 3, we use our arithmetic solution to answer the question in the problem. As you look at this list, notice that the most difficult step is by far the first one. Children who read word problems often have no clue how to turn it into an arithmetic problem unless it's one of the easiest types of problems. And this is why they're appealing to us to help them figure out whether it's addition or subtraction. However, notice that if you actually give them that answer, you are the one who's doing the hard work of step 1. They're not learning how to do it themselves, and then it ceases to be a problem. It even ceases to be a word problem at that point. All they're doing now is just arithmetic computation. They're not developing problem-solving skills. So we can support the learners in 2 ways. One involves visualization strategies with retells, and the other one involves visualization strategies through images. So we can spend time on ensuring that they're attending to the story. The first one, retelling, they can act it out in their mind. They can make a movie of what's going on. They can get visual images. So you're actively working on retell strategies, which is a good comprehension strategy in general. And this also can harken back to their level 1 strategies of acting things out. If they can imagine acting it out, they're in a better position to make sense of the problem. Feel free to change the context of the problem. Oftentimes you can stay aligned with your curriculum, but you can change the words to be about the children themselves and about things the children like to do, even if you maintain the same numbers and the same problem structure or type. I was once working with an urban child on a change unknown problem about collecting shells on the beach. This was a Midwestern urban child who had, I don't think, ever been to a beach. He was struggling. I changed the problem. I kept the same structure. It was still a change unknown, but it was now about him, and it incorporated the game of basketball, which he loved. That allowed him to actually make sense of the situation and solve it. Another important teacher move that you can use to support learners in the initial sense making is to insert a step. Instead of going straight from words to arithmetic, stop at a diagram in between. If they can go from words to a model or diagram, and then the diagram can imply a particular arithmetic option. And we're going to be looking at 2 different kinds of diagrams that can be drawn, number bonds and tape diagrams, which we've referred to before, so they should be somewhat familiar. First, though, we're going to talk about that retell strategy. This top problem that you see, after giving away 5 shells, John had 6 shells left. How many shells did he have at first? This is a start unknown problem, and we learned earlier that they are particularly difficult for many first graders. The more difficult the problem type, the more time that you need to plan for children to make sense. The speech bubbles here illustrate various ways of prompting children to make sense of the problem, and they range from pretty open-ended prompts to retell the story to much more explicit guidance, such as the speech bubble on the right is much more explicit, and that could be helpful for some of your students who struggle the most. A few years ago, I was teaching struggling students in an urban school, and I found that some of my students made sense of a problem fairly quickly, and they were ready to get started problem solving very fast. And then I had another group of students who just were nowhere near being able to do a retell. And I would have them reread the problem together and talk about it together while I got the rest of the class started on problem solving, and then I would come back with them. And I would work with them on some prompts, leave them to try to discuss it. Then I would go in and monitor what the students were doing for problem solving, come back, check in, can you do a retell now? If not, I would get more explicit with my prompts. And it was really rough going at first. But the students improved phenomenally in their capacity to do a retell, and I refused to allow them to get started on problem solving until they were able to do a retell, because it would have just been playing with manipulatives at that point, or messing around on the paper in their journal. They had to be able to make sense first. Another thing you'll find is that as children engage in solving problems, sometimes they lose the strand of their thought. They sort of forget what it is that they're about and what they're trying to figure out. So questions like the second bullet point here can help a child to refocus, revisit this original situation, remember what it is they're really trying to accomplish, and connect what they're doing on their page with what the word problem was originally asking. Being able to do a retell is one thing, but another problem that children face is being able to visualize the mathematical relationships. So we need children to be able to lift from the story a mathematical relationship that they could then use to figure out what to do. And that can be difficult for some students. So on this slide, you see two different visual models that can be used with the shell problem that we just looked at. Remember that the shell problem was a start unknown, which makes it difficult. And it also uses a take from situation, but the problem involves adding. So we don't want to tell the child that it involves adding. We want them to see this for themselves, but it's going to be hard. So these visual models should really be helpful. Now, one of the things that's going to be important is that they perceive that addition is going to be joining two or more parts together to get a whole, and that subtraction problems, I know a whole and I know a part, but I have a missing part. Now, if they have that idea, which we're going to talk about more in the final week of the class, if they have that idea and they're able to create a number bond like the one you see on the right, it will become obvious to them that this is an addition problem. Oh, I have the part that I gave away and the part that I kept, and then altogether that was what I started with. So they can perceive that more easily as addition. And then I have a tape diagram where we have an unknown amount. I don't know what it is, so I put a question mark there. But I know that that unknown amount has two parts, the part that I gave away and the part that I'm left with. So having dialogue about these images, incorporating the student's own involvement in building these images, and then trying to make sense of what that might imply for an operation. These can be very useful strategies for getting students to figure out for themselves what operation is involved. Now we're going to turn our attention to specific ideas for supporting learners with compare problems. This is a brand new class of problems for first graders, and they are difficult for many of the first grade children. Comparing is a skill that's built over time, and it will likely show up in different ways at multiple locations in your curriculum. So I strongly suggest that you do some assessment at the beginning of the year that will give you specific information about whether individual children understand and can use the concepts of more, less, more than, greater than, less than, and whether they can identify the difference between two numbers, just comparing numbers but not in a problem-solving context. Those should be kindergarten capacities, but they need to be examined again and determined whether interventions need to occur. It's also useful to observe whether individual children have the capacity to act out a matching situation using concrete materials, because the matching strategy with concrete materials directly leads into a mental or visualization strategy that we can look at. So these would be really useful things for your learners to have some experience with prior to a compare problem-solving unit. Another support for learners is modeling the use of tools for visualizing situations. And as I said, you can start with concrete, but then transition into the use of a tape diagram. Tape diagrams are specifically mentioned by the Common Core authors as being appropriate for compare problems, and you can find that on pages 12 and 16 of the Common Core Progressions document. Another support for learners that I mentioned was using visualization tools, and here you see kind of a transition of soldiers and horses. Initially, the soldiers and horses, that's actually from a kindergarten book. Children can trace with their finger and find out if there's more horses or more soldiers, and whether each soldier will have a horse or not. That can also be modeled with concrete counters and using a matching strategy. So that's the middle step, and then this can transition into a tape diagram that you see at the bottom. The tape diagram is very useful. It allows you to perceive that the difference is the amount that's extra, the number of extra soldiers that don't have a horse, or you can visualize it as how many more horses would I need so that each of the soldiers could have a horse. So that model helps you perceive that relationship. I mentioned earlier that poor problem solvers tend to pull numbers out and immediately want to do something, and they're not necessarily attending to the whole situation. And I also talked about slowing them down at that process to make more sense. One way to do that is to cover up the numbers. That's easy to do on a smartboard, but if I were working on chart paper, I could use Post-it notes, and I would read it with some. Mrs. Ray buys some pears and some oranges. How many more pears than oranges are there? Class, I want you to study this problem and tell me whether you think there's going to be more pears or more oranges, and what was the clue you saw that made you think so. What you're trying to do is get the students not to immediately gravitate to the numbers, but to begin to notice that there's relationships embedded in the words that they can unpack and that will help them to make sense of the relationships in a problem. Now, I've taken 3 problems here. These are 3 problems from a previous lesson that are all very similar. And when you look at the models that I drew for each of the problems, the models are also extremely similar, those tape diagrams. The only difference is really the unknown. Now, in the act of creating these with some student assistance, you can actually easily see where the unknown is. And that, once you have that relationship, it implies what you might do for an operation. So if you look at the very last model, the question and model, the one on the right, this is also a start unknown, and it uses the language of fewer, but if you look at the model, you'll see that to find out Mary's books, you're going to have to actually add Jenny's books with the 2 extra that Mary has. So the image, the model, can be very useful in helping children to perceive the relationship and to attend to those very specific things. Children have to carefully read these problems in order to be able to attend to how they are different from one another. So compare problems, in summary, are particularly problematic for many children. And if we examine the tape diagram carefully, we can see a couple of ideas that we want to elicit that could be very useful in helping children to visualize the mathematical relationships embedded in compare problems. Now, keep in mind that they should already have a background in part-whole relationships, where you think of a whole as being made of, say, 2 parts. However, here it is not at all evident that the smaller quantity is actually part of the larger quantity, because it's actually a separate quantity. And the whole is hard to understand because we're not combining these 2 quantities. So this is a difficult concept. We need to use these tape diagrams to help the children see some big aha, and that is that if you look at the larger quantity, you can think of it as being composed of 2 parts. The part that is the same as the other quantity and the part that is extra. And those are your 2 parts, and your whole would be those 2 parts together. So in this particular one that you see right here, you can begin to see that 5 is composed of a 4 and a 1. The 4 is like the other quantity, and the 1 is the extra bit, and that's the difference. So these tape models allow you to have conversations around the mathematical relationships. Now, it won't be easy. There are some really difficult problems in first grade, but try some of these tools and share some ideas that you have as well. Make sure